Hi, my name is Isma Hadji, and I am from York University in Toronto, and I'm presenting our spatiotemporal oriented energy network for dynamic texture recognition. So, in a nutshell, in our paper, we are presenting a novel spatiotemporal ConvNet that is completely learning-free. And our network was designed for spacetime image analysis in general, but our particular application in the paper is dynamic texture recognition. So, we have designed our network with these three goals in mind. First, we wanted to take advantage of the hierarchical nature of ConvNets, and that allows us to extract features that slowly progress from being simple and local to abstract and global. But at the same time, we also wanted to maintain interpretability throughout our network and minimize the many heuristic design decisions that are typical of ConvNets, such as the number of feature maps per layer or the number of layers themselves, as well as other important decisions like the pooling strategy and stride and whatnot. And finally, we also wanted to minimize the need for training because we do not always have access to large amounts of training data. And in fact, we minimized it so much that we got rid of training altogether. And so anyways, with these three goals in mind, we designed what we call SOENet. So at first glance, SOENet looks like your typical ConvNet with the standard building blocks. So in fact, we have used convolution, rectification, normalization, as well as both spatiotemporal pooling and cross-channel pooling. However, a distinguishing aspect of our network is that all the building blocks were analytically defined based on theoretical considerations. And thanks to that, we did not require a training phase, and we were able to exactly determine all the aspects of our network architecture. Another thing that I wanted to mention here is if you take a look at our paper, you will see that for each one of the blocks, we made ties to biological findings that sort of suggest we're heading in the right direction. So that's the first distinguishing aspect of our network. Now, the second distinguishing aspect is this nice recurrent connection or feedback loop. Thanks to this connection, we are able to use the same basis set throughout our network and repeatedly apply the exact same set of operations. However, we are still able to extract novel and useful information at each layer because the input is changing after each pass, thanks to the processing stages of the previous layers. So that's about our network. So now for the application, like I said, we worked on dynamic texture recognition. And in this slide, I am showing 5 typical examples of what we call a dynamic texture. So we have used this application for many reasons. First of all, because dynamic textures are all over the place, but also because they are basis for many important applications like video indexing and video surveillance, as well as dynamic scene segmentation and recognition. So we have used our network on this task, and using our network, we were able to establish new state-of-the-art on pretty much all the datasets out there, and that is even while comparing to your standard learning-based ConvNet. So that's our paper in a nutshell. Now, if you do want to know more, please stop by our poster. It's going to be number 13, and that's what you should be looking for. And thanks for your attention.